Hi Year 12. This video has a look at 5D, which is looking at the integration of exponential functions. We have not explicitly looked at this before, but the same rules as our usual integration are going to apply. I've written over here to the right to check your HSC formula sheet, which we'll have a look at right now and see there's a couple of formulas on there to help you out. So if you have a look at the formula sheet, which in our OneNote I'm highlighting the formulas as we use them. So the one that we looked at yesterday, you should have seen in the video, was our, I don't think I showed you that yet, was if we had y equals e to some function, when we differentiate it, we differentiate that function, put that out the front, and then we continue to keep that function that was there before for our exponentials. So moving on from that, we've also got on your formula sheet the integral of an exponential. So if we have an integral of some exponential with a function as a power, and it has the first derivative of that function out the front of it, then the integral of that would be e to that function plus a constant. So that would stay there. That's if we've got our first derivative out there. If we don't, then we need to think back to what we did last year with our chain rule, and then we may have to divide by what the first derivative of that function would be to get our solution. So that's there to help us and remind us. So you'll have that to look at those rules, but we'll go and have a look at how that actually works for us in some examples in our OneNote now. Okay, so our notes here tell us that reversing the standard forms of differentiation for the exponential function gives the standard form for integration. All that's saying there is basically that the integration and differentiation are reversed. So we need to remember that when we're working out our solutions here. So just like our HSC formula sheet, they're on here as well. When we differentiate an exponential, we get that exponential. When we integrate an exponential, we get that same exponential plus c. That's if we've only got an x in the function. So that's the very basic form. Underneath, these bottom two are the ones that we're really going to see a lot of. When we're differentiating e to some power that is a function, what we need to do is differentiate that function, and that comes down the front, and that e to the f of x stays in the power. If there's a number that's out the front of the e to the x before we differentiate it, like a 2, then we just multiply that by what our differentiated function power would be. Similarly, going backwards, if we were to integrate this, we'd end up with what we had to start with. So look at those as being reverse. So if I'm going to integrate e to the power of some function that has out the front of that an f dash of that function, so a first derivative, what I'd end up with would be e to my function plus c. Now that's what's written on your formula sheet, but that very rarely is going to happen, and we're going to have to play around with it and divide to get that to work a little bit, and that's what our examples below are going to do for us now. Okay, so let's have a look at this first example here. It's saying find the indefinite integrals. So here we're integrating e to the 3x plus 2 with respect to x. What you'll note is we don't have any values on our integral sign here, so we're going to have to go plus c because we don't know what those values are that we're going to have. Now, the way I like to think of this is thinking about our rules up here, thinking that if we're integrating, it's the opposite of differentiating. So I want to think about what I would have if I differentiated what's under here to start with. There's a couple of ways of thinking it. This is the way I find it a little bit easier to do. If I differentiated this, I would end up with 3e to the 3x plus 2. Now that formula's on our formula sheet, so if I'm differentiating an exponential with a function, I differentiate my power, in this case it's 3, and my function there in terms of the exponential will stay the same. So when I differentiate this, I get this. So therefore, when I integrate this side, I get that side. So if I integrate 3e to the 3x plus 2 with respect to x, I get e to the 3x plus 2 plus c. But what I'm doing is I'm wanting to integrate this, but I now have worked out what this is. Okay, so this is what we looked at the end of our year 11, our first year 12 topic, when we're looking at reverse chain ruling. So I now know that the answer to this one here, the integral of 3e to the 3x plus 2, is this. I want the answer to this one though, which is 1/3 the size of it. So I need to have 1/3 the size there and 1/3 the size there, and that's my answer. Okay, so with our exponentials, we'll have a look at what happens when we differentiate it And then we know, well, if we integrate that answer that we got when we differentiated, we have our new answer that we need up the top. That probably wasn't explained really well, guys. Just noting that they're the opposite of each other. So in this case, when I differentiated this, I got this. And I know that when I integrate this side, I'd get that side. I've written that down. I've integrated this side here, and I got that side there. Noting I wanted 1/3, the size of what I had the answer for, so I need to put 1/3 in there. Let's have a look at the next one over here. And we'll do that in a similar way over here. The difference will be that we have values on either end of our integral, so we won't have a plus c. We'll be able to actually calculate what that's going to be. So let's think of it the same way as what we did before. Let's differentiate what's under here. Now remember, when I just write d dx, what that is, it's finding the differentiated form of this, and that's our y. So it's basically dy dx. We're just writing it a little bit differently. So the differentiated form of that here is going to be -2, because we differentiate our power in our exponential. It goes down the front. Our exponential stays there as it was. It doesn't change. And we're going to pop these integrals on in a second. I just want to talk about what we've got. So when I differentiate this side, I get that side. So if I integrate this side, I'm going to get that side. So I'm going to do that. I'm going to write the integral of -2e to the 5 minus 2x with respect to x is going to be this side here, e to the 5 minus 2x. Now remember that that -2 that I've got there, I can leave that there, but if you like, you can also pull it out the front because it's a constant, and you might prefer to do that. Now, what have we got? We know that, and I'll just get a highlighter for us again, when we integrate -2 times e to the 5x minus 2x, I get this side here. But I only want e to the 5 minus 2x. So what am I out by? I'm out by a factor of -2. So I need to divide by -2, and I need to divide by -2 to get my solution. And what I also need to do is, oops, let's fix that up there, pop that in square brackets between 3 and 2, and then I need to substitute in to get my solution. So remember, we were popping in this value first into our function that's in our square brackets and taking away what we get when we pop in our value of 2. So I'm going to get e to the 5 minus 3 2's are 6 on -2. I'm going to pop that minus from the bottom up the top, because I don't like the minus on the bottom. Then when we pop our 2 in, we're going to have minus an already minus term, so it becomes a plus. And we're going to have e to the 5 minus 2 2's are 4 all over 2. So let's neaten that up. It's going to be minus e to the -1 on 2 plus e over 2. Now I think that looks a little bit messy. Let's neaten that up. Let's pop them all over 2. So I'll get minus e to the -1 plus e. I like the minus to not be out the front, so let's neaten that up a little bit again and write it as e minus e to the -1 over 2. You could have put the e here down on the bottom and had -1 over 2e plus e over 2. That would work as well. We could have done that. Or we could leave it like this, or we could actually factorize this one a little bit further. So I've had a couple of goes of factorizing this one to neaten it up. I would probably leave it like that. What we could do though is do something, if you see it, you might write the top line like that, and I'll show you how to do that from back here in a second. I could pull out a 1 over e out the front, and that would leave me in there e squared, because 1 over e times e squared is e, minus 1 all over 2, which would give me e squared minus 1 over 2e. I could do that, which doesn't really help me, but my top line then would be a difference of 2 squares. So you can have e minus 1, e plus 1 all over 2e. Doesn't really help us. So again, I'd probably leave it like this, but you may have found that over here, what you wanted to do was to bring the e down the bottom and pop it over 2e, and then you would have got it back over to this form over here. So I'm pretty happy if you leave it like this for now, but that's our solution. Just a lot of algebra. So what you might notice is the algebras